Hello everyone, my name is Sneha Srivastava and today I am going to explain the topic virtual work. So, firstly we will know what is work. So, we all know that force into displacement is known as work and we write it is as Fd cos theta. There are conditions which is if theta is less than 90 degree and greater or equal to 0, then the work which is done is positive, and if theta is greater than 90 degrees and less than 180, then the work done is negative. If the direction of force and direction of displacement both are same, then work is positive and vice versa. Now we will understand what is equilibrium condition. A body is equilibrium under the action of system of forces, then summation of fx forces is 0 and the summation of fy forces is 0 and sum of all moment of force acting on a body is 0. Now we will move toward the term virtual work. When number of forces acting on a body, then if there is no displacement in a body, hence force do not work. But in some statistical problem is suppose that body has imaginary displacement, then work done by all forces acting on a body which undergo virtual displacement is known as virtual work. अगर हम इसको हिंदी में समझें तो अगर हम लोग नंबर ऑफ फोर्सेस एक्ट कर रही हैं बॉडी पे और अगर कोई डिस्प्लेसमेंट नहीं होता उस बॉडी में, तब हम ये मानते हैं कि फोर्स जो है वो वर्क नहीं हुआ है, कोई वर्क डन नहीं हुआ है इस बॉडी पे. मगर हम लोग कुछ केसेस में ये सपोज कर लेते हैं कि बॉडी ने कुछ इमेजिनरी डिस्प्लेसमेंट हुआ होगा और जो भी वर्क डन होगा उस इमेजिनरी डिस्प्लेसमेंट में उसको हम लोग वर्चुअल वर्क बोलते हैं. सो नाउ देयर आर two principles of virtual work. The first principle is the necessary and sufficient condition that a particle acted upon by a number of coplanar forces to be in equilibrium is that sum of virtual work done by all forces for small displacement consist with geometrical condition for a system is 0. Now we have taken so many forces and we will move towards its equation. Let F1, F2, F3 till Fn are coplanar forces acting on a body as we have seen earlier in that diagram. Let x1, x2 and xn and y1, y2 and y1 are component of these forces along x and y axis respectively. So their summation will be x1 plus x2 till xn and for y it will be y1 plus y2 till yn. Now we will give some small virtual displacement O dash, where O has component O and O dash has alpha and beta. Then total work done for force F1 will be alpha x1 plus beta y1 and for F2 it will be alpha x2 plus beta y2 and we will move towards Fn alpha xn plus beta y1. Now taking total work done of all the forces, we will sum all these forces. We will get alpha x1 plus alpha x2 plus beta y1 till beta yn. The equation 1 becomes alpha summation x plus beta summation y. Now we will apply the necessary condition, which is we will take the body will be in equilibrium, then del x summation x will be 0 and summation y will be 0. Then equation 1 becomes del x, in place of del x we will write 0 and in place of del y we will summation y we will be writing 0, then work done will become 0. Now the sufficient condition is that we will let the total work done will be 0, so the equation 1 will be equated to 0. Then we have to show that body is in equilibrium. If we take small displacement in which body moves along x-axis only, we are taking a small displacement in the direction of x-axis only, so alpha beta becomes alpha dash and beta. As we are not taking in beta direction, in y direction, so beta will be written as this only. So alpha dash summation x plus beta summation y will be equal to 0. Subtracting equation 3 and 2, we will get alpha minus alpha dash summation x equal to 0. Summation x will come 0. Similarly, we can find del summation y equals to 0. So we will get summation x 0 and summation y 0. Now the body is in equilibrium. Now the second principle of virtual work for rigid body. The necessary and sufficient condition that a rigid body is acted upon by a number of coplanar forces be in equilibrium is that algebraic sum of virtual work is done by all the forces for any small virtual displacement consist with geometrical condition of a system is 0. Similarly, as the previous one, we will take same forces till Fn, but there is small changes is that we will take polar coordinates which are px1 y1 till pn xn yn, and their coordinates are r1 theta 1 r2 theta 2 along x-axis. Now y1 y2 y1 and x1 x2 xn are component of forces along x and y axis respectively. We have taken a position P where particle is initially and after small displacement it forwarded to point C. So from the initial point to point P, it makes an angle theta, and there is a shift of some distance which is del theta, and the displacement is same r1 r1. So on giving small virtual displacement to the system so that the point P1 takes new position Q, here it becomes Q. This is done by rotating body del theta angle, then making a distance parallel to x axis and B distance on y axis. From figure, del x1 plus del x1 is equals to OB from the triangle OBC, which is OB. From the triangle OAC, we will find the value of OB, which is OA plus AB. Substituting the values, A plus R1 cos theta 1 plus del theta 1. Now we will further calculate it and we will get the value of del x1 A minus y1 del theta, and in the same way we will find the value of del y1, which is x1 del theta plus beta plus B. So summing all the values to get the force F1, we will get this force which is written here: A x1 plus b y1 plus x1 y1 minus y1 x1 del theta. Similarly, the total force will be written as this, taking summations, sum of all forces along x-axis, sum of all forces along y-axis. Now we will be applying necessary condition as the previous one. Firstly, we will take the bodies in equilibrium, that is summation x1 0, summation y1 0, putting it in the equation 1, which was the total work done. We will get work done will be 0. Now the sufficient condition is that work done by all the forces is 0. So we will put the equation 1 with 0, and we will take a small displacement in x-axis only, and b is equals to 0, del theta is equals to 0, but a is not equal to 0. So by applying all these conditions, we will get x1 is equals to 0. In the same way, we will get y1 is equals to 0, and at last we get all these three quantities 0. So we can say that the body is in equilibrium. These two were the principles of virtual work. Now we will move towards its how to solve the questions of virtual work. So we will draw a rough figure of a body and find all resultant force or weight. If it is specified in the question that we have taken a string, then it will apply tension. If we have taken a rod, it will apply a thrust. Distance are measured from position of rest, and these will be positive along the force and negative in the opposite direction. Now there is a question which states the 6 equal heavy beams are freely joined at their ends to form a hexagon and are placed in a vertical plane with one beam resting on the horizontal plane. The middle point of the two upper slant beam, which are inclined at angle theta to the horizontal, are connected by light string. Find its tension in the beam in the term of omega and theta, W and theta, where W is the weight of each beam. So we have taken 6 beam, 1 2 3 4 5 6 connected horizontally to each other, and we have made a tension here. Since W weight each rod of hexagon is W, so total weight of the hexagon will be 6W, lies on the center of the gravity G here. Let 2a is the length of the each rod. On giving small virtual displacement, theta becomes theta plus del theta. So equation of virtual work will be here 6W weight is on the center gravity along LG. So minus 6W del LG minus T PQ, because the tension is applied here PQ. On solving, 6W dot del LG plus T del PQ. From the figure, we will find the value of dxc. xc upon dc is equals to sine theta. xc is equals to dc sine theta. dc is a rod and we have taken the length of the rod as 2a, so it will become 2a sine theta. Again, finding the value of k dash q. So dk dash q triangle gives k dash q upon dq is equals to cos theta, k dash q is equals to a cos theta. From figure, we can see that LG is equals to GM is equals to XC. So LG becomes 2a sine theta, as we have previously calculated the value of XC. Now PQ, P and Q, if we divide it in 3 parts, it gives PK, K dash and Q dash. KQ dash. K dash is this value, which will be equal to LD, and K dash Q value we have find from the triangle. So we get 2a plus 2a cos theta. Hence, putting all these values in the equation 1, it gives 6W dot del 2a sine theta plus T del 2a plus 2a cos theta. Further solving, we get tension is equals to 6W cos theta. So this was the tension which we have to calculate. So this was all about virtual work. Thank you.